So previous class we have seen the basic artificial neural networks and different types of artificial neural networks and everything. Now, so this is the comparison chart between the artificial neuron as well as biological neuron. Now we can say that is the dendrites we can compare with the input, then we can say it is performing the summation functions and we are having axon. So dendrites will act as a input signal and we have to do the processing, that is called soma, and we are having axon, that is the output. So we can compare with similar comparison with biological neuron with artificial neuron. Biological neuron consists of dendrites, soma, axon as well as synapse. Similarly, an artificial neuron consists of input units, then processing units, then output unit, then weighting updation. Here the input unit is equal to dendrites, then processing unit is equal to soma, then output unit is equal to axon. And similarly, for introducing the weight, we are using synapse. So this is the comparison between biological neuron as well as artificial neuron. So this is an important 2-mark question which they will ask in the examination. That is like compare the artificial neuron with the biological neuron. I am repeating once again. Here the input unit will act as a dendrites, then processing unit will act as a soma, output unit will act as a axon, then weight, that is equal to synapse. Here weight means, here dendrites means it receives the various information from other units and provides the input to the that is neurons. Here soma means it is a cell body where the processing will happen. Then axon means it is a long length fiber cable which connects the one neurons into another neuron. Then synapse is a smaller part which connects the different neurons, which provides the different values, that is nothing but synapse. Similarly, we can compare with this one. Here input means input unit, input samples what we are doing the process, then we are having processing unit, then there only we are finding the activation functions, and as well as we are doing the summation process. Like last class we have discussed the formula for y. Once again the y is equal to bias plus WI into xi. Then we have to do some thresholding functions by applying the activation functions. So what is activation function? Previous class we have discussed it. Activation function means it introduces the non-linearity. That is to a network it should learn the complex pattern. So for that purpose only we are using activation functions. So there are many different types of activation functions which we have discussed already in the previous class. Then we have got the output, that is called a axon, that is the output unit. So yeah, network based on the different types of network, it consists of input unit, then output units, then in between we are having lot of processing unit. That is, we can say, that is called hidden layers. So we know the input, that is input layers and output layers. In between that input as well as output, we can say it is a hidden layer. Why it is called hidden layers means we don't know what is happening inside the hidden layers. The network may consist of more number of hidden layers, and that's what in deep learning model there are many number of layers, that is input in the form of input layer, output layer, and we can say it is a hidden layer. There are many hidden layers are present in deep learning model. That's what we are telling that deep learning model is a black box model, because we don't know what is happening inside the hidden layer. Even though we are giving the input and we are getting the output, but what it is happening inside the hidden layer we don't know. So that's what in deep learning model they are telling that this is a black box model, because it provides the output but we don't know what it is happening inside this hidden layer functions. That's what they are calling is a black box model. That is nothing but the neural deep learning, that is deep learning networks. So this is the comparison between artificial neuron as well as biological neuron. So this is the simple model of a neuron. So here we have got input units, then we have got weights, then we have got summation function, then we have got output. Here the input is called input samples, what we are giving. It may be a text data or it may be an image. So what we are giving. So before implementation of the network, so first we have to perform the training data. Suppose if we are having 100 samples, we have to divide with some 80% of data can be used for training and 20% of data can be used for testing. Sometimes nowadays in a network they are dividing into 3 parts. One is called training and one more is called testing, and in between that we have got validation. For example, how we can able to understand means, like if you are preparing for the examinations, so training means you are studying. So what we are studying for exam. Testing means you are writing semester examination. So before going for testing, so we have to go for validation. That is nothing but it is equally compared with your internal examination. So So similarly a network, so we have to do three processes. One is called training and one more is called testing, and in between training as well as testing, so we are doing the that is called validation. Yeah, for example, if any given data, suppose if it is 100 samples means, so we have to divide the data, so we have to provide more importance for training as well as less importance for testing. So once all these training process completed, then only we can provide this model into real world applications. Then only it can perform it can predict it can work efficiently. So this is a model of the simple neuron, consists of input, then some, that is processing unit, then output. Here weight indicates, as already I have discussed already, weight means how much input information is important. It defines the importance of the input information, that is called weight. So to reduce the error, so to make the training model perfect, then we have to update. It is the only changing parameters. We can't change the input, we can't change the output, but what we can make, we can change the weight as well as bias. So by updating the training parameters, that is called weight and bias, then only we can we can minimize the error. So the important parameters are weight, bias, and one more parameter is called learning rate, alpha. That is how much learning is we are doing. If we are learning very fast or very slow or moderate, that is nothing but alpha. How much learning process we are doing, how much learning, how much weight we are updating, how much learning we are, that is called alpha. So these are all the different types of parameters which we are using in the deep learning, that is simple neural network. So first we have to provide the input and we have to perform the formula, that is y is equal to, that is summation function, that is nothing but bias plus WI into XI, that is we have to perform. Then output, we know that we have to apply any activation function, or we can take directly the outputs. So input unit, processing unit, then output unit. So input is nothing but input, processing means we have to perform the summation function with as well as with activation, then we have got the output units. So we have in the network in a real time, so if we have to find out the that is target value as well as actual value, and we have to find out the error, and based on that error, so during the training we have to minimize the error. So what we have to make, we have to provide the feedback, then accordingly we can vary the way, that is parameters, that is weight as well as bias, then accordingly once again we can find the error, then up to minimum error or error is 0, we have to do the training, that is the network is learned, that is training is stopped, then we can go for testing. So this is the real picture in terms of deep learning, that is neural networks model. So this already we have discussed it. Yeah, this is nothing but a model of neuron. Okay. So next class we will discuss about the structure of artificial neural networks.